Hello students, next on the line is we have algebraic inequalities. And so we've taken some time to learn about equations. So let's remember that an equation is when you have an equal sign between two numbers. Now, if you take a look at the word inequality, it's saying not equal, right? And so what does this mean for us? Well, it means that you are dealing with a number that is greater than or equal to, or less than or equal to. This means that the value isn't just going to be, it's not just going to be straightforward, right? It's going to have a range of numbers. And so let's take a look at an example here of what would an equation be versus an inequality. So an equation can be x is equal to 4, which means that x is 4. It's that simple, right? It can only be one number and that's it. Now, the inequality version of this is when you say x is, let's say, greater than 4. Now, when we're saying this, that means x is greater than 4. So in other words, x can be any number that is greater than 4. So 5 is definitely greater than 4, 10 is definitely greater than 4, 4.1 is greater than 4, or 4 and 1/20ths, let's say, is greater than 4. So any of these can be 4. In fact, usually we would say that x is all of these numbers. So it's any number that you choose that is greater than 4, that is definitely what x is going to be equal to, or can be equal to. Now, this is good for us sometimes because when we're setting up rules, we want to say that, well, any value that's greater than 4 is like good. So for example, so let's say, how can we use this? Well, let's say x is a passing grade. And in a typical school, we would say x, usually you would have to get no less than or at least greater than 50%, right? So then if you get 51%, well, that's passing. 52, 80%, or 100%. Those are all passing scores. So that's why we use inequalities. It's to express that there are a lot of these possibilities. So now let's take a look at solving these. And let's go with another section here where we say solving inequalities. Now, if you have been following my steps, this should pay off tremendously nicely. So let's say we have an example here and we have 3x plus 4 is equal to, or no, oops, my bad. Let's go with is greater than or equal to 16. So you might wonder, okay, how is this going to be different than an equation? Now, let's just start with following the steps, all right? I'll show you how the majority of the steps that you do is going to be similar to what we've always done. So in this case, let's say that, you know what to do here, right? I'm going to minus 4. I'm going to minus 4 from both sides because I'm isolating. So the isolating still happens. And then I'm going to be left with 3x. And 16 minus 4 is 12. Actually, don't want the arrow there just yet because I'm going to expand this. So then I'm going to divide both sides by 3. And I should be left with x. On the other side is 4. Now, remember how I said always draw the arrow there? So remember that what we're doing is we're taking this symbol, I'm going to highlight on top, and what I'm doing is I'm bringing it all the way down to the bottom there. So when I write this down, I'm going to write x, I'm going to repeat that symbol instead of equal sign, and 4, and that is my answer. So if we want 3x plus 4 is equal to 16, then we know that the number has to be greater than or equal to 4. This actually makes sense if you try to plug it in. So sometimes I like to just think of one number that's greater than 4. let's try like 5, right? And if I were to plug 5 into the top, so let's say you could choose to write this down, or you could choose not to. 3x plus 4, 16. Let's say I plug in 5 in there. So I know that this will be 15 plus 4 is greater than 16. And 15 plus 4 is 19. 19, is it greater than 16? Well, yes, it is true. So that is correct. And if you want to disprove, or if you want to prove the opposite, that anything less than 4 is not the number, is not x, then you could try that out. And you'll see that it's true. Okay? So that's how we deal with inequalities. Now, I highly recommend you use the exact same method that we've been doing it. Do not get thrown off because of this symbol. This symbol only replaces the equal sign. There is, though, one rule that you must follow. So let's put this down. One rule to follow. All right, so what we're doing is, if you are following my steps, it should still be the exact same method, but one rule, let's put an exclamation point to remember this. If you multiply or divide by a negative, you must flip the inequality. Now this is true as well with numbers with equals, like with equality or equal signs, equations. But the reason why we don't make a big deal of it is because if you flip an equal sign, it's still an equal sign, right? So we don't actually see that. So let's take a look at the example here. Okay, so we're gonna say 3, and let's keep it simple, minus 2x is, let's say, greater than, and let's just only use greater than, is greater than, let's say 7. All right, so we still use the same method. Now in this case, be careful, because I'm going to deal with this side right here, right, the left side, and this right here is actually a positive 3. So then the opposite of that is minus 3. So that's going to be what I'm going to do, right? So minus 3 and then minus 3. That helps me get rid of those. So I'm left with negative 2x. 7 minus 3 is 4. Now, watch this. Divided by negative 2. If it is divided by a negative on both sides, I have to flip the symbol. So what I'm going to do is I'm going to redraw the symbol right here to remind myself, look, I flipped it to become this. All right, you see how it's flipped? So now what's negative 2 divided by negative 2? Well, I'm left with 1x, and then 4 divided by negative 2, this is going to be negative 2. All right, so if I put this down for the symbol, I'm going to follow that arrow. Oh, there's that flip. So then it's going to be less than negative 2. Now, what does this mean? So if I have negative 2 right here, the number that I'm going to choose has to be on this side of it. So negative 3 would be a number that's less than negative 2. I am going to test that out. All right, so let's test it out. And let's test it out to the original equation. So let's see. 3 minus 2x is greater than 7. But now the number has to be less than negative 2. So let's say I'm going to put in negative 3. 3 times negative 2 times negative 3. Okay, right? 7. And then if I put, so let's see. If I put that number, then it will be 3 plus 6 is greater than 7. What's 3 plus 6? It's 9. Is 9 greater than 7? Yes, it is true. All right, so 9 is greater than 7. That means it is correct. Now, if I didn't flip the number, that means I would have put a number that is, or if I didn't flip the symbol, that means I would have put something that is x is greater than negative 2. So let's try. A number that is greater than negative 2 is, let's just say, like 0. 0 is greater than negative 2, or it's bigger than negative 2. So then if I try that out again, 3, oops, minus 2x is greater than 7. 3 minus, let's say 2 times 0 is greater than 7, which means 3 minus 0 or 3 is greater than 7. That is not true. So you see how if I didn't flip the symbol, it would mess things up. Now, that's the one rule you must add to your attention here. If you multiply or divide by a negative, you must flip the inequality. So I'm going to give you one number to test this out, and I would like you to try working on it. And what I would like you to do there is copy down. Yeah, so just copy this number down and then try it. You could pause it after, and I'll do the working right after that, okay? It's gonna be less than or equal to, and let me try something out here. All right, I think that should work okay. So go ahead and pause this, and then you can press play when you're ready. Here we go. I'm gonna use the method where I expand it. So what I'm going to do is I'm going to multiply these numbers in. So I'm left with 2. Oh, nope. I'm left with 8 minus 6x. The rest is the same. Okay. Now I could start trying to isolate it. The 8, it's a positive there, so I have to do minus 8. So those cross off. I'm left with negative 6x on one side, and then negative 22 plus negative 8 equals negative 30, right? Because they're both the same symbol, so it's the same number. And then it's negative plus a negative, so what they do is they become a negative. Now I will divide by negative 6 to get rid of that negative 6, and I'll divide this by negative 6. Now, remember the symbol, it must switch. So I'm going to flip that symbol like that. Cross off the 6's there, extend this line. I'm left with x, and negative 30 divided by negative 6 is positive 5. So bring that symbol down, the later one, and then x must be greater than or equal to 5. That should be your answer there. All right, you could test it out, put it in there, and see if it's true or not. If it does have the equal sign, you can put the 5 in there just to see if it works. But you could always choose a number that is greater than or equal to 5. All right, that is it.